Hello guys, welcome to S Academy guys. So this is my fifth video on this G+6 RCC building design series. So in this video I'll be just continuing with my previous continuation of my previous lecture where I have assigned dead load and live load using in StatPro. So this video will be continuation of my previous video, and I'll be including few things which I have missed in my previous lectures. So in my last lecture, that is lecture number 4, I have mentioned that we will be applying the live load as per the room occupancy. So and unfortunately I was not able to mark that locations of a room as in my AutoCAD. So I'll be just applying a live load of 4 kilonewton to entire room, because if you see that the live load on your first floor, it is coming around 3 kilonewton, 300 kg, that is 3 kilonewton. So basically this consists of all your rooms, like your kitchen, your living room, your bedroom. So this is around 3 kilonewton. Then when you go to the staircase, it is around 5 kilonewton. So toilet, it is 2 kilonewton. So basically I've just I've taken the average, and I've on conservative side I have applied 4 kilonewton of live load. So we will be proceeding with that 4 kilonewton of live load. And a dead load, few of you have commented that why we have not deducted the dead load of wall at the window location and door location. So we are not modeling those ducts, because that those are only partition walls. So you can do one thing. If you want an optimized design, you can just deduct the door and window size, and you can apply the actual loading. That you can easily do for optimized design. But keeping since this is a tutorial, so I've just tried to make my design more conservative so that it will be easier for you to design. So regarding the dead load and live load, wall loads was dead load, your floor loading for slab, and your live load. So we have just assigned those loads. So this load was assigned double, because if you'll see, this load has been assigned to few members. I'm just continuing my last video. So I'll just delete this load because this is not required. So self weight, then your wall load, then your floor load as per your slab thickness, that is 150 slab thickness. Live load is 4 kilonewton applied on all floors. So this is your dead load and live load application. So now once we are done with dead load and live load, then we need to assign the earthquake load and wind load. So in this video I'll be assigning that earthquake load and wind load. The detailed calculation of earthquake and wind load, I'll be coming up with further calculations. So in this video I'll be just assigning the earthquake load and wind pressure wind load, and I'll be explaining the methods which are necessary while designing for your earthquake. So once we have assigned the dead load and live load, if you then you have to define. Actually the definition of wind and the definition of earthquake would have been earlier. We should first define the seismic definitions. So just click on seismic definition, click on add. I've already uploaded a video on how we assign seismic loading as per static method. So before, how we come up to this conclusion that we have to use static method or we have to use dynamic method? Since we are doing high-rise buildings, so we need to take a proper care whether we have to go for static method or dynamic method. So how do we conclude that we need a static or dynamic method? So we are designing as per IS 1893/2002. So for that we have to refer IS 1893 Part 1 2002. So here you will just if you refer clause 7.8, I'll just go to 7.8, Control F. Clause 7.8, if you'll observe, then there is a condition where you have to use static and dynamic. Like static you can use anywhere, but for dynamics you have certain conditions. Dynamic analysis shall be performed to obtain the design of seismic force and its distribution to different levels along the height of the building and to various lateral loads. So this is part of IS 1893 Part 1 2002. This code has been revised. So we are still using this code. So if your building is there is a category of buildings, regular building and irregular building. So those buildings, those regular buildings whose height is greater than 40 meters. So if the building height is greater than 40 meters, so in our case, I'll just close this. Let's just measure the height of the building. This is ground floor height. So we have 22.4. So if your height of the building is greater than 40 meter, if your building is regular, so if we consider it as regular, so our height is less than 40 meter in height in zone 4 and 5. If your building comes under zone 4 and zone 5, that is above zone 3, so those greater than 90 meters in zone 2. So if your building is under zone 4 and 5 and height is more than 40 meters, then and regular building, so you have to go for dynamic analysis. And if your height is more than 90 meters and your zone is zone 2 and zone 3, like, so we are designing for zone 3, so we have this condition. So our building is under zone 3 but height is less than 90 meters, so we have to go for static analysis if we are considering this building as a regular building. But in case, let's assume it is irregular because the shape it is unsymmetrical and those things, let's assume that. So all frame buildings higher than 12 meters in zone 4 and 5. So if you are in zone 4 and 5 and your building is higher than 12 meter, then it should be designed for dynamic analysis. And those greater than 40 meter in height, so in our case, if our building is 40 more than 40 meters or 40 meters, so we have to go for dynamic analysis. So hope you're clear about the selection of static and dynamic analysis. I have uploaded video on both static analysis and dynamic analysis. I've also uploaded how to assign static load using STAD Pro. So let's get back to the design problem. So we are doing static analysis for this building because the height is 22.4 meter. So just click on seismic definition, add. So we have to generate. So select IS 1893, generate, click on generate. So either you can go city wise or you can go your zone wise. So just zone is very simple. City we can't, I just don't want to waste time searching this city. So zone 3, zone coefficient special, we are considering it as a special moment resisting frame or ordinary. So you have ordinary, these are the options: ductile, shear wall with ordinary. If you are providing, these are your conditions. So for that you have to consider a clause, table number 7. If you'll go where you'll get table number 7, so that basically depends your detailing, whether you have to go for ordinary detailing or you have to go for ductile detailing. So if we are using special moment RC frame, moment resisting frame, SMRF, so for that your response reduction is 5. And if we are using ordinary moment resisting frame, so your response reduction should be 3. So you have this, you can see these are the suffix. So just what does that note means? So you have to refer note number 2, and so note number 3 says SMRF definition. So we can go, and note number 2 suggests if you have an ordinary moment resisting frame, then the detailing will be as per IS 456 or IS 800 if you are designing steel structures, and but not meeting ductile detailing requirement as per IS 1390. But if you are designing SMRF, so just refer to clause number 4.15.2. So if you go, the definition, it is a moment resisting frame with frame specially detailed. So if you are using special moment resisting frame, then your detailing will be as per IS 13920. So now, so let's get back to our problem. So we are designing a special moment. So actually that marking, that note mark is not, you cannot say that it is a suffix, just you consider it this as a note. So that 2 and 3 have meanings, so that you will find uh, in the bottom of this page. So 2 means this 2 you have to, for ordinary moment resisting frames design as per the detailing is as per IS 456, IS 800 for your steel and 456 for your RCC. Otherwise, if you have a special moment resisting frame, then detailing will be as per 13920. So let's get back to, so we have a special RC moment resisting frame. If your building is a general or important building, so general important building, the important factor are also given in IS 1893. So you must be aware of that. I'm not going that in deep into the. I'm just by an importance you can give as per your requirements. So there is no, there is limitation of importance factor for few important building, but you can give more importance to your buildings. Like if even if you have a residential building and commercial building which comes under normal buildings where the importance factor is 1, you can give it 1.5. You can have conservative design. So your soil type, hard soil, medium soil or soft soil. Select medium soil. Structure type, RC frame building, or you have steel frame building, or any other type of building. Any damping ratio 5%, just click on generate. So once you click on generate, click on add. So you're just this, close this, because we are assigning seismic load in terms of your dead load and live load. So we have defined seismic parameter. So for this you have to, actually for dead seismic loading, the participation of dead load is 100%. Like if you, the 100, the dead load is completely participating during your earthquake. And live load, for live load participation, there are certain conditions during earthquake. So for that we have just a condition where your live load is more than 3 kilonewton per meter square. Then your earthquake live load participation, if the imposed uniformity UDL floor load is more than 3, then your seismic load participation of live load is 50%. But if it is less than 3, then it is 25%, that is 1/4. So in our case, our live load we have considered 4 kilonewton. That means the live load participation is 50%, that is half of your live load. So we'll just copy. So I've already uploaded how to assign seismic loading in STAD Pro. So I'll just use that. You don't need to do much. You just click on STAD editor. Once you click on STAD editor, just copy these loads, like this live load and self load, self weight, dead load and live load. Just copy this, just copy and paste below your seismic definition. So where we have defined seismic, we have defined seismic load zone, you just copy here. While copying, just please keep in mind you don't copy the direction. So for y direction in self weight and negative, then you just remove that. For your member load, you just remove this. Floor loading, you just remove this sign, this and the sign. And also you just please keep in mind that these things are not coming. This load conditions like your dead load or live load, just remove that. Otherwise it will ask that your dead load and live load does not have any direction, so it will give error. Now this is your, once your seismic load ends, this parameters end, your normal loading will continue. Just click on save, close. Now once you click on definitions, you have under seismic load, self weight, member weight. You have this member weight. You also have assigned floor weight, but somehow it is not visible. Let's check what is the problem. So this member weight, it is not showing floor load, so I'll just check. So we have assigned that floor load for seismic. I'll just show you. Just scroll it down. So now we have assigned this floor load is for your dead load of your slab, and this is for your live load. Live load we have applied 4 kilonewtons, so 50% of 4 kilonewton is uh, uh, 2 kilonewtons. For that we have I've already discussed that we have a clause in IS 1893 where if your live load is less than 3 kilonewton per meter square, then you have to consider 25% of your live load for seismic calculation. But if your live load is more than 3 kilonewton per meter square, then your live load participation during earthquake will be 50%. So we are using 50%. So just let's get back to the problem. So once you are done, I'll just explain you one more thing. Like, so if you have a secondary beam. So actually this STAD Pro ETABS, the default setting is that it considered all joint as a fixed support. So in order to, if you have a simply supported beam, or if you have a secondary beam, then your support condition is different, it is not fixed. So for that you have to release a moment in either a two direction or all the three directions, or you have to release a moment in one direction. So for that you have to just click on this commands, click on member specification, release joints. So once you click on release, you will be getting these options whether you are releasing more forces or your moment. So I'll just click on moment, click on add. So once you click on add, this moment release option has been generated. So once you click on this moment, it's closed. There under general specification, this is available. So select any random beam. So if I'm selecting these two beams, I'll just assign to those selected beams. So with these notation, it will be visible that these beams are released. So during analysis, I'll show you the difference between a release joint and a normal joint. I just click. So seismic is done. Now we will be just moving to the definition of wind. So once you just click done seismic, you have to just click on define wind definitions. So I'll just go, I've already analyzed, I'll just use it. So now we have to define the wind definitions. So just click on this, I have already defined, just delete. Click on wind definition, click on add. Once you click on add, just write type 1. If you are using wind with different directions, so you can segregate it as a type 1, type 2, type 3. So just click on this type 1, just click on add. So I'll just, for this lecture, I'll just give you a brief idea how wind load is applied. So we calculate wind pressure as per your internal pressure coefficient, external coefficients, all those gust factors as per your height. So working with all those factors, coefficients, your K1, K2 and K3 factors as per IS 1893. IS 1893 is for part 3 is for your wind loading, so where your dynamic effects. So these, after considering these all factors, I'll be coming up with wind loading with a different set of videos, so that in that video I'll be coming up with more calculations for this. So I'll just show you an example. Like for this, we have considered 0.6 kilonewton per meter square of wind pressure up to height 10 meters, 0.7 up to height 15 meters. So these are the wind pressure worked out point. I'll just 0.84 up to 20 meters, and 0.9, let's say 0.9 up to 25 meters. Our structure is 22.4 meters. Just click on add. So factor, just click on add one, close. Exposure, assign to view, just assign, select this, assign to view. So exposure, so we have defined wind, we have defined seismic. Now we have to add seismic load. So I've already added, so I'll just remove this. Initially in my previous lectures I have assigned first dead load and then, so in my previous lecture I have assigned a dead load and live load where the numbering of your dead load and live load was 1 and 2. But when you analyze this structure, this model where your dead load and live load is numbered 1 and 2, and after dead load and live load if you are assigning the seismic load, then it will show an error. Just I'll show you one example. Just click on add a load case. This is seismic, so eq positive x. So because earthquake is along you have both x and z directions, click on this, click on add, just click on seismic loads x factor 1, click positive x it is. So now just try to analyze. Once you click on analyze, I'm just showing the example why you'll get an error. So you are getting an error. That means your model has not been analyzed properly. So once you click on the error, it will say IS1893 load has not been, that load IS1893 load case must be defined before any other load case. That's why we need to define this load case earthquake as load case 1, 2 and 3. So I'll just add, and I'll just cut and paste using this stat editor. So eq minus x. So I have already generated eq plus x minus x plus z minus z. So I'll just do one thing. I'll just go into stat editor. You can do the same. So before that, I just want to confirm that I have assigned that seismic load in all the direction. So so I have assigned plus x minus x plus z minus z. So you just need to go to stat editor, just copy these 1 2 3 4 5 6 before 1 2 3 4 before 5 and 6, load case 5 and 6. So it is the main motive behind this exercise is in order to make you aware that please don't create load case at EQX seismic after this dead load and live load. So just copy the load cases of earthquake seismic before your dead and live load. So seismic is this load case 1 2, it by default take load case control X, just do cut and paste. So before this is type 1 define, this is after wind definition just before. So I've just assigned this, so just save it. Otherwise you can do one thing, you can delete your dead load live load and again create that load and live load. So that will be again a time consuming and a tedious, and again you have to assign that dead load live load. So this EQ earthquake we have just assigned initial starting when we have assigned earthquake. Now try to analyze. So once you try to analyze that error, there is no error, your model has been successfully analyzed. So we have analyzed for earthquake loading, dead loading and live loading. So we have also assigned a seismic wind parameters. So I'll just assign a seismic wind loading. Seismic is done, dead live is done. Now wind loading. So just be in the modeling phase. Just I'm close general load combination. So just click on add. Once you click on add, type of load wind. So similarly wind plus x we did in seismic, same thing we have to do in wind plus x minus x plus z minus x. So once click on plus x, click on add. Similarly you have to just go to wind load positive x factor plus 1. This range is because we are in this case we are assigning a floor, that is surface loading on for your wind. That's why we have to give this y, z and x range. So for positive, you just let it be 0 0 for positive x and positive z. So once you click on this positive, then negative x, just click on negative, just click on wind load negative factor -1, just click on add. Now we have to just change the this. If you'll close, you'll see this is this load has been assigned to the same surface but in the negative direction. We have to assign this on this face. So for that, you have to your x range, you have to just change, click on edit. So your x range will be somewhere between your 16 meter, 15 meter to 17 meter, because that the length of that, so this face it has been assigned. That range is defined based on the length. What is the length? This is 14.6 or this is 18.7. So actually the length should be more than 16.55, more than this length, this surface. So more than this surface, and uh, should be greater than this. So the range between this two. So this positive x, negative x. Similarly, z, wind, wind, positive z. Click on add. So when loading is added. Similarly for your, so wind load has been assigned. So all the wind loads has been assigned, and now your wind, earthquake, dead and live. So now we need to create the load combinations. Load combinations. So we have already in our DBR. So if we'll go to the DBR, so we have already discussed about the load combinations. So right now I won't be going as per the load combination of the DBR. I'll be just using the auto load combination command. So we'll just check, just click on add load case details. So once you click on load case detail, you have this load generation, define load combination or auto load combination. So once you click on define load combination, so these individual loads with their factors, like click if you are using 1.5 1.2 times of EQX, then 1.2 times of dead load, 1.2 times of live load. So you just need to just do this alpha value you have to assign. So if you create the load case 1.2 times dead, 1.2 times y, dead 1.2 times of positive x, so you just click on add, that load combination will be created. So I'm just to save time, I'm just creating an auto load as per IS 456. Just click on auto load combination, just click on Indian code, just for general structures, generate load case. Once click on this, your load case has been, combination has been generated. So your load combination has been generated. You can just click on analyze. Once you click on analyze, your structure will be analyzed for all these load. So once your analysis is done, you just need to go to post processing mode for your designing and for your member forces, for your reactions, for the design of foundations. So just click on go to post processing mode, just click on done. So once you click on post processing mode, these load, individual load, these are the cases. So that's it. By default it takes all the load, individual load as well as the load combinations, but we don't want the reactions for all individual loads, and sometimes we don't want the reactions for all load combinations. So just make this whole thing on this left hand side and just select those load cases, you load combinations you want the analysis. Just click, select whichever you want. You want to deselect, you just go back to this. So select all these, click on OK. So once you click on OK, all those load combinations, the analysis result will be only for all those load combinations. So these are the displacements, nodal displacements. You have beam, forces, you have reactions. So these reactions will be at your support. So this is the reaction for individual nodes. This the summary will have the maximum reactions. Those maximum reactions are highlighted. So you can take these reactions, this load case. So you can take these reactions and you can design the foundations. So each and every, if you want to design the foundation for different foundation for each and every support, you can use each and every load case summary. You can use for each node 60, 62. So for all these nodes, or for all nodes, so you take this result, you use this result and design the foundations. For members, if you are designing these members manually, like you are designing beam and column manually, slab we are already designing manually, so you can just click on beam. So the forces of these beams, like if you select these beams, this beam, so the forces on this beam, these are the moments. The forces are very less. If you click on this beam, there will be more moment compared to the top beam, because here the loading is less. This column, the moment forces will be less, more compared to this column. So individual reactions for members are obtained from this analysis output. We can also design using StatPro. I have already uploaded a method of designing the RCC members using StatPro, so you can refer that method and you can try it by yourself, so that in next video, if when I'll explain, you will get a clear picture. So you, by that time, you will have your own design with these load combinations. So this was regarding the analysis output. So let's get back to the modeling. I have just said we use that release moment release. So let's assume this is a secondary beam. So we want to release a moment. So just click on member specification, release. So I'm releasing moment in all the direction. Just add. So I've assigned. So this you can assign using this start assign to the selected beam. So once you click on assign to the selected beam, it will just get assigned. There will be a circle at this node. So just click on analyze. Once you click on analyze, it will give the same out. So we are using the same method. Just go to post processing mode. I'll just take any of the any load combinations. I'm just showing what is the use of this moment release function. So click on beam. So we have released a moment. That means this beam should not have any moment. So just click on this beam. So once you click on this beam, there is a zero moment in this beam. So let's check for other beam. If you will click on this beam, which is continuous with this beam, there are moment on this beam. That means this moment release function helps you to release the moment. Like for a secondary beam, if you are using, then that secondary beam does not transfer any moment to the main beam or the column. So that is the benefit of moment release. So in this problem, we are not using any secondary beam, because the length of the grid is very small. Like if the slab, this direction it is 3.25, this is 2.95, so the slab design will be under our control. If this is if this is 6 meters, so we have to just provide a secondary beam along this direction, so that the span of slab will be reduced and loading distribution will be proper. So hope this moment release is clear to you. In case if you have any doubt regarding this, so I was talking about the DBR. So DBR, we have just uh, uh, created these load combinations. So you can, so as I said, just I'll get back to the modeling. So you can just generate your load combination. This load, just click. So as per DBR, we can just create a load combination, define load combination. So the DBR suggests first load is 1.5 times dead load. So I'll just show you how to create the dead load. Dead load is 5, just 1.5 times. So this is your user generated dead load combination. So just click on, so 1.5 times dead load. Now next loading is 1.5 dead load plus live load. So next dead load and live load combination, both 1.5. So 1.5, 1.5. So this loading is also done. So we have created two user defined load combination. Let's see, we can generate one more. So 1.5 dead load, 1.5 earthquake x direction positive. So we have generated this third user defined load combinations of load combination of 1.5 dead load and 1.5 earthquake load. So we'll just analyze for, and we see the reactions for only these three user defined load combinations. So once this analysis is done with zero error, if it will show any single error, then your analysis report won't be generated. So just click on done. So we will just see these three load combinations. Will observe the result for these three load combinations. So just I've just shown you the result of these load combination, these three. So as I said, this moment release, if you observe this beam, there is zero moment. Then if you observe the beam next to this beam, then there is moment in this beam. So hope this auto load combination is also clear. The user defined load combination is also clear. The seismic loading is also clear. The wind, regarding wind loading, have only applied the wind pressure at a different level. I assume that most of you are aware of the wind pressure calculations. Yeah, I'll be definitely coming up with the numerical problem on seismic wind pressure calculation in my next video or in my upcoming videos. But this was the main concept behind is to help you understand how we proceed the design of RCC building. Actually, most of you must be aware of these small things, like how we calculate dead load, how we calculate seismic load, how we calculate wind load, but how do we actually proceed for this design? Like since from the commencement of your line diagram, your architectural drawing, your DVI preparation, your modeling, and your analysis, these all things I'm just using these, explaining these all things in order to make you understand the problem of design. There might be possible I have missed something while explaining. I have misquoted certain clause. I might have done any miscalculation. So the concept behind this is purely to explain you the exact procedure. How do we proceed for a structural design of RCC building? Mostly I'm trying to explain most of the concept. So if you have any doubt, if you have any doubt, please comment. We will try to conduct lecture videos on your doubts specially. So regarding this topic, regarding this series, if you have any doubt, please come up with the doubt now, so that we can include those doubt in our upcoming videos before we finish this series, so that it will be included. If I have missed something, then you can point it out and we will try to include. If I have explained it something very in a very short manner, like I said, I have explained the wind loading in very short and precise manner. So I'll be coming with the detailed calculation behind wind load. So similar kind of doubt you can generate, and you can ask those doubts. We will try to clarify. So thank you. Have a nice day. Take care. Goodbye. And please subscribe to our channel and keep sharing our videos. And please press the bell icon so that you can get continuous notifications regarding our upload. Thank you. Have a nice day. Take care and goodbye.